Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. We'd like to thank Code for sponsoring our live streams and podcasts from the Software Circus in Amsterdam. Code is a team of passionate open source engineers and advocates building community through contribution and engagement in emerging technologies. According to thecodeteam.com, it's not just a bunch of pillars and stuff we say. It's the core fundamental of what we believe open source provides. That's what drives the Code Team. You can learn more about the Code Team again at thecodeteam.com. Gareth Rushgrove of Puppet, and you're here giving a talk on the nested nature of software and bug hunting.
Yep.
Tell me, what is this theme you're trying to talk about? You know, as we kind of get through, as you kind of do your performances here at the circus. And the Software Circus is quite a show, isn't it?
It is quite a show.
Yeah, we're here with you because the Code folks at Dell asked us to come here and they sponsored these live streams. I want to thank them. But this is unique, right?
It's pretty special. I was here last year as well, and this year they've gone all out on the circus theme.
Yeah, the first year they were like throwing around top hats. So.
Yep, and this year, I think where the few of us speaking are speaking in a sort of religious theme sort of ceremony nearly for the audience.
Yeah.
So yeah, there's it's certainly high concept for a tech conference.
Yeah, there's like this theme of mythology about it, isn't there?
Yep, and well, I think different tracks got different sort of like nearly sort of art project-esque sort of amateur dramatic things going on. One of the groups are doing it. There's some of the talks have been presented along with a guitar accompaniment, which is a new one on me. But yeah, no, it's all good fun.
And you're talking about deeply nested nature of software and programming. What does that mean? Why are you talking about that?
So I did a short talk on basically the story of a single bug in a single very small bit of software. The reality is that steps from that small bit of software to another bit of software, to another bit of software, to actually the Open API descriptions for Kubernetes, into the Open API specs, version 1, version 2, version 3, and actually then into a Go library. And the sort of I think increasingly the software we're building is it's not all in one. It's not the historical monolith. Whether it's microservices or whether it's libraries, whether it's using software from elsewhere, you're relying on so much other bits that when it comes to actually finding bugs, you end up looking in an awful lot of places. And often when you're fixing bugs, you're not going to fix them in different places. And sometimes that'll be the right place, sometimes that'll be the fastest place, sometimes it'll be more expensive to fix it in different places. And I just think that that's sort of interesting, especially as we move increasingly towards like microservices and those things become about the services, not just libraries, not just sort of something for a software developer.
Right, so the distributed nature, like applications using API calls to call on other applications.
Exactly. If you're building towards this sort of microservice ideal, sort of cloud native sort of architecture, for a service, actually for a thing a user is doing, maybe buying something, there might be tens of services involved, and you get into all of that as actually finding a problem in that. Well, it could be anywhere. It could be in the connections between them, it could be in the services, it could be in a library supporting multiple services in different versions. It gets quite interestingly complicated, even though the individual bits of software are all really small. And I think that's interesting.
Yeah, it's like when just any everyday consumer, there's some way their bandwidth slows down, and they're like, what just happened? It could be anything, right?
And one of the things I'm sort of come back to in the talk is around just the importance of specifications and standards. I think sometimes especially sort of developers on the cutting edge, can sometimes, because they're working with software that moves so quickly and standards and specifications tend to move slowly, they can tend to sort of push those to one side. but without those strong like specs and standards and things like OpenAPI, things like gRPC, protocol buffers, having these strong like bits in the middle that tie things together, I think you can build very fragile systems.
So building fragile systems, using approaches such as with gRPC, for example, what are you experimenting with?
And I've done quite a bit with probably a little bit more with OpenAPI, but also some bits more recently with gRPC for different types of applications. I think it depends on whether actually HTTP is useful in the context of what you're doing. But I think both have and they seem to be the ones that are having both most users at the moment, but also feel right for the domain they're in. And they're both evolving as well, which I think is good. And they're sort of, there's certainly some overlap between them. There's certainly some bits where they're slightly different, and certainly in the Kubernetes context, which I've been doing some of this work in. A lot of the Kubernetes internals are gRPC, but actually the external API is API. And there's some gaps there around, for example, how they do types differently. So again, even though we have these discrete specifications, it would be nice if there was more interop or more discussion about that as well, standards and protocols.
And so this theme around this, that's the nature of software and bug hunting, kind of is a good kind of example to kind of explore these.
Yeah, I sort of explore all that sort of highly concept stuff with the tale of one bug. So a very simple bug in a tool I wrote called kubval. So it's basically a tool for validating Kubernetes configs. So you might be handwriting them in YAML. I would prefer less people did that. But you might be generating Kubernetes configs in Helm or KSonnet or with the Puppet module we have out there that people can use to interact with Kubernetes. But in all those cases, you want to ask the question, is this valid? And often in cases, is this valid against multiple versions of Kubernetes? So if I write a config file and I put it in a demo or an example or a module or whatever, I want to be able to say, not just it works for me on the version of Minikube I happen to be running today, but does it work on these different versions of the API? If you look at the evolution of Kubernetes, actually, if you look at different versions, they have new constructs, then they have changes to existing ones. And be able to say, yes, this config file is valid for all these is powerful. So we have a tool called kubval, but that had a bug. And it saw the story of one of these bugs actually, and the actual program is a couple of hundred lines ago, but the actual dependency chain is much, much longer. And the bug ends up sort of several steps beyond. I think it was sort of an interesting example of just highlighting why.
Yeah, that's very interesting because the trail can be long even if the source is small, right?
No, that's the thing. The software increasingly able to write powerful software with very little code because of this sort of weight of open source libraries, the package managers around it, serverless functions or microservices. All of these things about being small. But that's the iceberg to what's actually running that software. And so that whole sort of supply chain, the whole sort of infrastructure piece, and the fact that bugs often sit in a combination of all those, it's the interaction between all those things where the bug exists. Interesting problem.
I could talk to you all day about this, Gareth, but I want to just stop it here. But before I do, what are you doing at Puppet these days? What's keeping you busy?
I'm working on all sorts of different bits at the moment. So I've spent a lot of time sort of focusing on, Puppet and sort of container space. So we've done a lot of integration with Docker Data Center more recently, and with Kubernetes. But I'm actually working across a number of different teams at the moment and some of the sort of, either problem sort of hunting or some research bits. Variety of different things. But yeah, there's still a lot going on at the bit around, again, container story, but also support for the long tail of network devices, different operating systems and hardware. Something that Dan Cohen was talking about today, how do you take people from their existing infrastructure, their existing software stack, and without saying you have to rewrite everything. And I think that's one of the things where Puppet sort of spans multiple generations of people doing different things. Like that's sort of the core sort of, I guess, thing I keep coming back to like every day.
Well, Gareth, thanks so much for taking some time to talk, and look forward to keeping in touch, and enjoy the circus.
Yeah, you too.
Listen to more episodes of the New Stack Makers at thenewstack.io/podcasts. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.